All right. So again, 3.11. If we look at the overview here, again, this is basically like your wrap it all up, your study guide for the entire unit. Okay. Oh, wonderful. All right. This lesson will help you review what you've learned so that you're ready to take the unit test. All right. With the checkup here. All right. With the checkup. Okay. Again, these are super helpful. I really suggest that you make sure you look at these or save these or have these somewhere handy, because it gives you all the formulas that you guys are going to need for your tests right at your hand. Okay. This first session is talking about the quadratic formula. All right, so it's talking about the quadratic formula, and that's that x equals negative b plus or minus square root of b squared minus 4ac all over 2a. I know that was a lot, right? So again, please feel free to look this up, to have a picture of it somewhere, anything. All right, couple things I want to remind you of. This plus or minus here, that means you're going to do the entire problem in the positive, right? So you're going to do negative b plus all of that, and then you're going to do it again, negative b minus all of that, right? And it will give you one of three options, right? As we found out, it'll give you two real answers, it will give you one real answer, or it will give you two imaginary answers, also known as zero real answers, okay? So moving forward here, it says factor the polynomial expression, all right? So a lot of these here, it's gonna depend on if you can make it a perfect square, if you can use your equation p plus q, right? All of that stuff. And I'm trying to load this on my iPad for you so we can actually just walk through it together. And we'll choose a couple key examples here. All right. So perfect, I've got this on my iPad. Let me share this out with you all. All right, perfect. Okay. So again, for factoring the polynomial expression, we worked on a lot of different ways to factor this, all right? But the two main ways that I always think of is that p plus q version, right? And then the completing the squares. Okay, so those are the two things that I normally think of is p and q or completing the square. All right, so we'll try to do a couple of each of those and work through how to do this. All right, but before we do that, right, just to make sure that we're totally clear, if we're gonna look at let's look at 1, 5, and 6. Okay, we'll do those problems. So I'll circle them. All right. When you start these problems here, you've got to look for a couple things. First off, you have to make sure that there is no exponent. So that thing that's raised to the power of, there's no exponent greater than x squared, right? There's no x3, there's no x4, x5, so it has to be x squared, right? And it has to include x squared. So if it was just 6x minus 7, right, then we couldn't factor this. That would be a linear line, all right? So we got to make sure we do that, right? And then the next thing we got to look at here is the signs. So if we're looking at number 1 here, we've got a negative sign and a negative sign, right? And if you go back a couple units here, depending on if you took a screenshot of it or not, there was that little flow chart, right? And it said, if the second sign is negative, you go this way. If it's positive, you go the other way. All right, but basically what you're trying to figure out is, okay, if I've got a negative sign here, if I'm looking for my p and q and then p plus q, all right, when I multiply p and q together, that has to give me a negative number. So what that's saying is one of these definitely has to be negative. Okay, one of these definitely has to be negative. Now, this one I think is kind of easy, hopefully, because there's only two things I know that can get multiplied together to give me negative 7. It's either negative 7 and positive 1 or negative 1 and positive 7. All right. Now, when I add these two together, P plus Q, negative 7 plus 1 gives me negative 6. All right. And this one would give me positive 6. So obviously that one's going to be my answer here, right? So I have x minus 7, x plus 1. All right. And again, I can do that because there's a 1 out in front of this, right? So I end up with my form x plus or minus p multiplied by x plus or minus q. All right. And again, the easiest way to always check your answer before you hit submit to make sure that you're right, just FOIL it back out. If you can get the original expression or the original equation back out, your answer is correct. Okay. Now here, if we look at this guy, all right, if we look at number 5 here, that's where we have it in this different form, right? We have it in this different form. It was that capital A squared minus capital B squared, right? And this is one of those perfect square examples. All right. So we look at this and we say, okay, well, what two things multiplied together will give me x squared? Oh, obviously x. All right. All right. But then when we look at this guy here, we kind of ignore the negative sign for a second, right? And we know that b has to be 10 because 10 squared gives me 10. Or sorry, gives me 100. All right. So we know that a is equal to x and b is equal to 10. All right. So this is where we get in that form of a minus b multiplied by a plus b. Okay. So what that's going to look like is x minus 10 multiplied by x plus 10. All right. And again, it has to be 1 negative, 1 positive because we have minus 100. Because minus 100. And when we multiply these together or we FOIL this out, right, I have to get positive 10x minus 10x so that I have no x value there. Okay. So that's one of our perfect square examples. All right. Now, if we look at number 6 here, all right, notice you've got a positive and a positive. All right. Next thing you need to notice is that this is a perfect square and 9 is a perfect square. All right. So we got to notice that. And if we write down again what a and b is equal to, a is equal to x, b is equal to 3 because 3 squared gives me 9. All right. 3 squared gives me 9. Okay. And then if you remember this middle part here, this is going to give me 2ab. So 2 times a times b. So 2 times x times b. That gives me 6x. All right. So this is the general equation for what you see below here. All right. And when we factor this, we end up getting x plus 3 multiplied by x plus 3. All right, x plus 3 multiplied by x plus 3. And as we found out, we can then combine these. So it's x plus 3 squared. X plus 3 squared. All right, because two of these multiplied together, we can just shorten that as x plus 3 squared. All right. So if you see it in this form, right, when we factor it, it's just a plus b squared. All right. So when you factor it, if you see it in this top form, a squared plus 2ab plus b squared, it ends up in a plus b quantity squared. All right. Now, another version, you could leave the answer. Oh, sorry. You could technically leave the answer like this. All right. So if there's a multiple choice option, it will not give you both of these. Okay. If there's a multiple choice option, it will not give you both of these because they're both technically correct. All right. So just make sure that you know that this form comes because we have two of those guys. All right, just in case they give you the top version on your multiple choice test here. Okay. So that's if we have a positive and a positive. All right. And I want to do one more here. If we have a negative and a positive. Oops, sorry. If we have a negative and a positive, but we look here, okay, x squared, that's a perfect square. 64, okay, that is a perfect square. So that is actually 8 squared. All right, and if you remember, if you don't know if something's a perfect square, you plug into your calculator the square root button and then your number. All right, and if it gives you a whole number, great, it's awesome, right? You know that that's something that gets squared. If it's something like 62 and it's 7.95, that is not able to be simplified. Okay, that's not able to be simplified. But we know that 64 squared gives us, 8 squared gives us 64. 8 squared gives us 64. But, all right, this is positive and this guy is negative. All right, so it's not actually positive 8 squared. It's actually negative 8 squared. All right, negative 8 times negative 8 is still going to give me positive 64. All right, so this is still in that form of a squared plus b squared plus 2ab. All right, it just looks a little bit different. A is still x, b is still negative 8. All right, and if I multiply 2 times x times negative 8, that'll give me my negative 16x. All right, so this still goes in the form x minus 8 multiplied by x minus 8. All right, and that then gets simplified further to x minus 8 squared. All right, x minus 8 squared. All right. Before we keep going, does anyone have any questions here on 1 through 8? Any questions? I know we took a ton of time on this stuff, and the reason that is because you found out you've got to be able to factor to do a lot of these other problems here. Okay. And and almost all except for the first video is your first lesson is posted in video. So please, again, go back and watch those. You can always go back to and look at the Apex lessons, right? So if factoring is not your thing, right, and you're a little bit confused on it, go back to the lessons that were specifically on factoring, and you can re-walk through those Apex lessons, right, all the way up till the end of the course. You can still walk through those. All right. All right, so for 9 through 12 here, find the solutions to the quadratic equation. All right, and again, I will just copy. Oh, sorry, it says equation, not formula. All right, says equation, not formula. So my mistake there. All right, so what we're looking for when it says find the solutions, we are looking for the answer to x. So we're solving for x here. All right. And so the hint for problems like this is you first need to factor, and then we use that zero product rule, right? And basically the zero product rule says if I have A times by B and that equals 0, then either A equals 0, B equals 0, or A is 0 and B is 0. Okay, so that's what that product rule means. So let's do, we can do number 10 here and number, well, that's easy. We already did that one basically. Let's do 11 and 12. Okay, so again, we check to make sure, is it x squared? Yes, great. All right, is there a 1 out in front? Yes. All right, so then that means we are then looking for, is this a perfect square and is this a perfect square? All right, well, 10 is not a perfect square. So then we look at our rule for P's and Q's. P, Q, P plus Q. All right, and obviously we've got a negative sign. So we've got a negative sign. So that means one of these values has to be negative. All right, and there's a couple combinations that will give us negative 10. So that's negative 10 and 1, negative 1 and 10, negative 5 and 2, or negative 2 and 5. All right, when I go through and I add these together, I either end up with negative 9, positive 9, negative 3, or positive 3. Okay, and obviously I need the one that's going to give me that positive 3. All right, so when I go and write my factors, it needs to be in that x plus or minus p plus or minus q form. So that's going to give me x minus 2, x plus 5. All right, so again, that's that factoring that we should know how to do. That's step 1. So we did step 1, we factored. Awesome. All right, now step 2 is we use that zero product rule. All right, so what that's saying is since this is equal to 0, since it's equal to 0, we split up our two factors. So x minus 2 is equal to 0 and x plus 5 is equal to 0. All right, now we have to get x by itself. So to get rid of that negative 2, I'm going to add 2 to both sides. So x is equal to positive 2. And x is also equal to negative 5. All right, x is equal to positive 2 and x is equal to negative 5. All right, so we used our zero product rule. All right, we solved. And then step 4 is always to check. All right, is always to check. So by that, again, you plug your answers back in here. So if I look at the first one, 2 squared plus 3 times 2 minus 10 should equal 0. So I've got 6 plus, oh, sorry, not 6. Bad math, Miss Judy. 4 plus 6 minus 10 equals 0. Well, 10 minus 10 definitely equals 0. All right. Then we go back through again and we check it with our other answer. So I've got -5 squared plus 3 times -5 minus 10 should give me 0. 25 minus 15 minus 10 gives me 0. Well, 25 minus 25 gives me 0. All right, so we double check, make sure, and if your answers both work out, then you know that everything you did is correct. Okay, your answer is perfect. All right. Any questions on this one before we keep going here? All right, so again, if it says solve, or find the solutions, okay, you're trying to figure out what x is equal to in this equation. All right, so again, the steps are factor, use the zero product rule, solve, and then check. Right, and by solve, I mean do the mathematical operations to get x by itself. Okay, if we do this next one here, x minus 4, we're still going to follow the same process, but we got to start off with, does it have an x squared? Yes. All right, so we know we're dealing with a polynomial, a quadratic too. All right, and then what I noticed here is there's no x term. There's no 1x or 4x. Okay, so then the next question you ask is, are these perfect squares? Well, if this would be in the a squared minus b squared form. All right, a is equal to x, b is equal to 2. All right, so perfect, we know that. So this is going to give us that form, a minus b, a plus b. All right, or x minus 2, x plus 2 equals 0. All right, so we factored. Now we use the zero product rule. So x minus 2 has to equal 0 and x plus 2 has to equal 0. Right, if I do the operations to get x by itself, x is going to equal 2 and -2. All right, so I did the zero product, I solved, and now I'm going to check my answers. All right, so if I plug in 2 here, 2 squared minus 4 equals 0. 4 minus 4 equals 0. All right, and then the same thing, -2 squared equals 4. All right, -2 squared still equals 4. All right, and this is a, I don't want to say hint, I want to say calculator check. All right, when you are plugging this into your equation, I know 2 squared isn't the most difficult thing in the world. All right, but let's say maybe you have 9 or 12 and you can't remember what those are. All right, when you plug this into your calculator, you have to put the -2 in parentheses. You have to put the -2 in parentheses. Else, it will do order of operations. And by that, I mean if I wrote -2 squared, what the calculator would see this as is, oh, okay, 2 squared. And it would go -4. All right, it would square this first, and then it would take the negative sign, right? So you've got to make sure you're putting parentheses. And when in doubt, put more parentheses than you think is necessary. Okay, put more parentheses. It's never going to hurt you if you're doing squares, right? It's never going to hurt you to put a number in a parentheses when you're doing the square value. All right. So again, that's this middle section here. Find the solutions to the quadratic. All right, we just did. All right, and again, the biggest thing there is factoring. Okay, the biggest thing there is factoring. Then we add a small baby part on to our factoring, which is that zero product rule. All right, now next little section here. It says find the value of c that makes the polynomial a perfect square trinomial. All right, so this is that completing the square. This is completing the square. All right. So if we do both of these here, all right, step 1 for this. Sorry. Okay. So when we realize, we've got to realize what equations we're dealing with. So by that, I mean, if we look at the two examples here, you've got a negative positive and you've got a positive positive. Okay, you've got a negative positive and a positive positive. So when I say that, what I mean is you've got a squared minus 2ab plus b squared. All right. Or you've got a squared plus 2ab plus b squared. Okay, plus b squared. All right. And so this is kind of easy for us because a in both of these cases is equal to 1. A is equal to 1. So it's saying find the value of c that makes it a perfect square trinomial. All right, well, in this example, a is equal to b squared in both of them. Or sorry, c is equal to b squared in both. All right, it's equal to b squared in both. All right. Now what we can do is we can use this middle term to figure out the value for b. To figure out the value for b. All right. So since we know that a is equal to 1, what we can say is negative 2ab is equal to negative 14x, right? It fits that equation. All right, plug in what we know. Negative 2 times 1 times b is equal to negative 14x. I'm left with negative 2b is equal to negative 14x. And I skipped a small step, so let me erase that just for clarity. It's 1x. All right, it's 1x. So negative 2x times by b. All right, so if I divide both sides by negative 2x, I am left with b equals 7. All right, b equals 7. Okay, now this is where you've got to be super, super careful. We're looking for c, and c is not b by itself. C is b squared. All right, so when we do the final step here, b squared is equal to 7 squared. So b squared is equal to 49. It is equal to 49. All right, it's equal to 49. All right, so going to the next one here, again, we figured out what form we are in, okay? And we figured out, again, we're still solving for c. So c is equal to b squared. So what we can do here is 2ab is equal to 8x. So we plug in for a. A is equal to 1x times by b equals 8x. 2x times by b equals 8x. Again, we divide both sides by 2x. So b is equal to 4 in this case. And again, you got to double check. We're looking for b squared. So b squared is equal to 4 squared. 4 squared gives us 16. So c equals 16. All right, c is equal to 16. And in case I didn't say this, all right, let me backtrack here. The reason I knew that it was either in this form or this form is because it used the term perfect square trinomial. Perfect square trinomial. So if it uses that word or that phrase, that means that you are in the form a squared plus or minus 2ab plus b squared. All right. So if it uses the phrase perfect square trinomial, you are talking about this form here. You are talking about that form there. All right. And again, when we factor that, it is a plus or minus b squared. Plus or minus b squared. Okay, again, depending on which sign you have. Okay. All right, so now for 15 and 16 here, find the solutions to the quadratic equation by completing the square. All right, so completing the square, that is your key there. All right, that is your key there. So again, we are looking for, oh, sorry, my computer just froze on me. Okay, so for this one here, completing the square. All right, so when we're completing the square, this is where we are going to add, right? We're going to add that b divided by 2 squared term. All right, so we're going to add that b divided by c, or divided by 2 term to complete the square. Okay, so our steps are to add that term, then to factor, and then to solve. All right, so we add that term, we factor, and we solve. So we then look at our equation here. Okay, so I've got x squared plus 6x. All right. One thing I want to highlight here, 7 is already on the opposite side of the equal sign. Okay, so that makes it really simple for us. But if x wasn't on the opposite side, so if it looked like this, step 1 would be to put it in this form. Okay, so I could even add it as step 0 here. You have to have your constant on the opposite side of the equal sign. All right, so this one already had it. But again, if it starts in this green form, you have to put it in the form that we have in our table here, or sorry, in our equation here. All right, so let me erase this. We are looking for b divided by 2. And when I say b, because we have ax squared plus bx plus c, right? That's our quadratic equation. So our b value over here is equal to 6. Our b value is equal to 6. So what we're looking for is b divided by 2 squared, or 6 divided by 2 squared, which is equal to 3 squared. Oh, I don't know why I wrote a cube there. Sorry. It's giving you the answer. 3 squared. 3 squared gives us 9. It gives us 9. All right. But we can't just add 9 to one side of the equation. We have to add it to both sides, right? That's why when we write this, we write it with that blank spaces. So we fill in the blank here for 9. So our answer ends up being x squared 6x plus 9 equals 16. Okay, equals 16. Now I'm going to move some stuff up for the sake of space. So now we've got our equation, all right? But we're looking for the solution. We're looking for the solution. So that means we've got to solve for x, right? But now it should be a lot easier for us to solve because we now have our perfect square. So our perfect square is going to end up with an x plus 3 squared form equals 16. It's going to end up with an x plus 3 squared form. And again, the reason I can get that is because I have x plus 3 times x plus 3. That ends up looking like x plus 3 quantity squared. If you don't believe me, you can always, again, FOIL it out. All right, but this is what we just worked on above. All right, so now I've got x plus 3 equals 16. X plus 3 equals 16. All right, I've got to solve for x. So I have to take the square root of both sides. Right, I've got to take the square root of both sides. So when I take the square root of the left side, all it does is it cancels out that superscript 2. So I end up with x plus 3 equals. All right. Now, this is where we worked a lot on. If this is something that can be factored, great, you factor it, right? And if it's not something, then you can leave it as this square root value here. All right. So what I mean by that is when I type in square root of 16, that gives me 4 in the calculator. All right. But it is plus or minus 4 because as we found out, negative 4 squared is 16 as well as 4 squared gives me 16. So we're not really sure. It could be positive or negative 4. All right. So then what we do is we set up 2 equations. We set up 2 equations. X plus 3 equals positive 4 and x plus 3 equals negative 4. All right, so I move 3 to the other side in both of these cases. What the heck did I just do? Sorry. Minus 3, so that gives me x equals 1 and x equals negative 7. All right, so what I just circled or boxed in, those are my final answers there. Okay, those are my final answers. So x equals 1 and x equals negative 7. All right, and again, I'll leave this to you just for the sake of time here, but we would plug both of those answers back in to double check to make sure, right? And you plug it into your original. So I guess, you know what? Heck, I'll do it since we're already talking about it here. Okay, so I plug these guys back in. So 1 squared plus 6 times 1 equals 7. So 1 squared is 1 plus 6 gives me 7, right? We can do that one. Now the next one is negative 7 plus 6 times negative 7 equals 7. Sorry, negative 7 squared. Negative 7 squared is 49 plus negative 42 or minus 42. That's going to give me 7 as well. All right. So the easiest way to check and make sure that your answers are correct is to plug them back in. I know it takes a long time. Trust me, I know it does. Okay. But it's the easiest way to make sure that you got the right answers. All right. Now to go through this next one here super quickly. All right. B is equal to 12. B is equal to 12. So in order to do this one, we've got to add a b divided by 2 squared term. So 12 divided by 2 squared, that is 36. All right. So I add 36 to both sides. So I end up with x squared plus 12x plus 36 equals 25. Equals 25. All right. Then when I take my perfect square, I end up with x plus 6, x plus 6 equals 25, or x plus 6 squared equals 25. I take the square root of both sides. That gives me x plus 6 equals plus or minus 5. I set up my 2 equations. X is equal to negative 1, and x is equal to negative 11. All right, again, you plug them back in, plug in, plug in. You're going to find out that those are the correct answers. All right, and again, hopefully what you're noticing, the biggest thing here is factoring. Okay, it's factoring. You've got to be able to factor these expressions. All right. Last little section here for 17 through 20, use the quadratic formula to find the solution to the quadratic equation. All right, so that is from above, our x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, so we'll pick a couple of these here, and I'll pick something that looks a little wonky. All right, perfect. We'll do 17 and we'll do 19. All right, so if we start off here with 19, okay, if we start off here with 19, so our key here is just to find the values for A, B, and C, and then we plug them in, right? So A is equal to 2, B is equal to, B is equal to positive 3, and C is equal to negative 5. All right. So we have those values. Then what we do is we just plug them in. All right. So negative 3 plus minus square root of negative 3 squared minus 4 times 2. Sorry, I don't know why I keep doing the negative sign for 3. Apologies. Minus negative 5 all over 2 times 2. All right, all over 2 times 2. Okay. Then we start to simplify the terms that we can. So plus or minus, square root. 3 squared gives me 9, minus 4 times 2 is 8, minus 5 times by minus 5 gives me a plus 40. Okay, that gives me a plus 40. Divided by 2 times 2 is 4. All right, so x is equal to negative 3 plus or minus the square root of 49 divided by 4. All right, well, the square root of 49, if we plug that into a calculator, is 7. All right, so x is equal to negative 3 plus or minus 7 divided by 4. All right, so I'm going to do 2 versions of this. X equals negative 3 plus 7 over 4, and x equals negative 3 minus 7 over 4. All right, so negative 3 plus 7 gives us 4. X equals 1. Or the other option is negative 10 over 4. All right, and if you want to reduce that down further, negative 5 halves. All right, so again, I know I spaced those out pretty far here, but the key is to make sure that it's in standard form. Make sure it's in that standard form so that ax squared plus bx plus c equals 0. If it's not in standard form, you get it to standard form. But once it's in standard form, it's pretty simple. You just find a, b, c, and you plug it into your equation. You plug it into your equation. All right. Last problem here, that we'll do for the study guide here. Okay, so again, we check. It is in my ax squared plus bx plus c equals 0 form. So now I'm just able to look for a, b, and c. So a is 1, b is 2, and c is minus 4. Then I just plug into my equation. Plus or minus square root of 2 squared minus 4 times 1 times negative 4. All over 2 times 1. All right, so I start to simplify here. Square root of 4 plus 16. 4 plus 16, all over 2. So this is looking like plus or minus the square root of 20 over 2. All right, now here's where we can get some different variations. Here's where we can get some different variations. All right. Square root of 20 does not reduce into something nice. Okay, it's a number. I think it's like 4.62 something something. Okay, so it's harder to get that number down. Okay, so you're gonna see this answer in a couple of variations. All right, the first variation you might see for this answer is x is equal to, we've got to do the positive version, and we've got to do the negative version. Okay, so technically, this is your answer. This is your answer here. Okay, you've got the positive version and you've got the negative version. All right. Other ways you could see this answer. Okay, this is going to be the majority of ways you can see this answer. The other ways you could see this, is if you divided both of these numbers by 2. All right, if you divided them both by 2. Now again, it's harder to divide that number by 2. So what you'll probably most likely see is x is equal to -2 divided by 2 gives me -1 plus square root of 20 over 2. X equals -1 minus square root of 20 over 2. All right, so that's another way of seeing that answer. All right. And then the final way, I know this is excessive, but I just want to make sure that you can be as successful as possible. The final way you could see this is if you actually plugged into your calculator this exact thing or this exact thing, right? If you actually calculated this out, you would get a number that looks like x equals 1.24 and x is equal to -3.24. And yes, there are more decimal places after that, but usually we just round to 2. Okay, so you could see an answer that looks like this, which just means you need to make sure you're plugging everything into your calculator correctly. So what that would look like is you would type into your calculator equals -2 plus, I would personally put a parentheses, square root of 20. And all of that is in a bracket, divided by 2. Or you do it in multiple stages. Okay, or you do it in multiple stages. You type in equals -2 plus the square root of 20. You get an answer. Type answer divided by 2 gives you 1.24 or whatever. Okay. All right. Obviously, there are a lot more problems here left. Okay. I tried to do as many as I can in a reasonable amount of time here. Okay. But hopefully what you're noticing here, people, is that for the checkup, they're not asking you the super specific nitpicky ones, okay? They're asking you for the general idea, okay? They're asking you for the general idea. All right. Now what we're gonna do here is we're gonna finish up the last 20 minutes with the review. Okay, so we're gonna finish up the last 20 minutes with the review here. All right, so you have this, right? You have this review here. Okay, it breaks it down for you lesson by lesson. Okay, do you know what a quadratic trinomial is, right? Example, can you identify a difference of squares, right? So use this, okay, and then check yes or no. And if you can do that, awesome, right? If you can't do that, go back and look at it. And how I use this, okay, how I use this is I keep this open along with my other notes. So if there's a question, right, if there's a question, and let's go to completing the square. If it says blah, 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 to complete the square. If you get stuck, you come back here and you look for, okay, where does it say completing the square? Where does it say that? Okay, lesson 5. Then you know to go back on Apex to lesson 5 here. Okay, you got to go back to lesson 5 here to look at that stuff. All right. But here, okay, here's the main thing. So for factoring x squared plus bx plus c, all right. 2 important properties. Okay, it's got to have 3 terms for it to be a trinomial, and the highest exponent has to be 2, right? That's the main thing here. Okay, to be that quadratic trinomial, it's got to have the exponent is 2, and there's got to be 3 terms. FOIL, first, outer, inner, last. Okay, you told me you knew that one, so we'll blow you through this. All right, and then when the factors of A are different, okay, so basically saying, again, here's that second sign. If it's positive, you follow this, right? And if it's the first sign, it's going to be x plus p, x plus q. If it's positive and negative, you're going to follow this one, right? Again, this is, I think, super helpful here if it's not obvious to you right off the bat. Okay. For factoring ax squared plus bx plus c, all right? This is a trinomial where the leading coefficient is not 1. Right? And we didn't have a lot of those in our checkup here. Okay, we didn't have a lot of those in our checkup. So please make sure you go back and look at this. All right. But the first thing is can you factor out A? Can you factor A out of everything? If you can, right? Then you take A out and you treat this like a normal quadratic equation. All right. You can treat that like a normal quadratic equation. If you can't factor it out, okay, if you can't factor it out, or you can factor out a small part, but there's still an A value that's not 1, you're going to end up with this Rx plus or minus P times by Sx plus or minus Q. All right, and again, the rule for that is R times by S has to equal A, right? It has to equal that leading coefficient. And P times by Q's got to be the constant, right? Like we've normally done. 3 tips for choosing the correct sign, okay, is if the sign before the constant term is positive, then both factors have to be the same, all right? If the sign before the constant is negative, then obviously they have to be opposite. And then the last one there, again, is super helpful for me at least. If you can, factor out the negative sign from A. Factor out a negative sign. All right, and then they should have added a 4th one here. Make sure you FOIL back out if you're stuck or confused. Make sure your answers FOIL back out and give you the right thing. Okay. These are your special cases. So 3 point, I believe it was 3 was your special cases here. All right, so the difference of squares. We worked a lot with this one, that a squared minus b squared. It's going to give you that general form, a plus b times a minus b. Right? If you don't have that written down somewhere, write it down. It's the easiest one you can find, hopefully. Okay. Perfect square trinomials. Okay, that's where it's either in this positive version or this negative version. All right, and depending on if it's positive or negative, it's going to tell you it's a plus b or a minus b. And those values are going to be squared here. All right. And I guess I can go back here. The biggest thing with the special cases is figuring out what capital A stands for and figuring out what capital B stands for, right? Is it X? Is it 1X? Is it 3X? Is it 16, right? Figure out what capital A and capital B is, and that'll help you because then you can just go straight to that final answer there. Okay, solving quadratics. Again, that means you're looking for the answer to A. All right, so when you are solving quadratics, if they're in standard form, again, that's the easiest thing, right? Going back to that standard form. You factor the quadratic expression, right? So give me those 2 factors, use that 0 product rule, and then solve for x, right? Solve for x. You should get 2 answers most of the time. If it's not in standard form, right? Put it in standard form, factor, 0 product rule, solve, okay? And then if you've got a perfect square trinomial, you still factor the perfect square. You take the square root of both sides, right? You simplify the answer. All right, so if you can take the square root of it, take the square root of it. If you can't, you leave it as that square root of whatever. And then you solve both equations. All right. If we go to the next one here, completing the square. What does it mean to complete the square? It means to add numbers in order for us to get something easier for us to factor. Okay, so the rule for completing the square is you add b over 2 squared. B over 2 squared, right? You got to add it to both sides of the equation. And as you noticed here, it's in that form x squared plus bx. There's no constant term. So if you have a constant, you add it to the other side of the equation. Get rid of it. All right. Quadratic formula. Just find that equation. You don't have to memorize it. The trick here, though, is a cannot be 0. If a is 0, then this is just the equation for a linear line. Okay. The one that we probably had issues with are these imaginary and complex numbers. All right. So hopefully there's not too many of those on your test. I believe there might be 1 or 2, but it's not a whole ton of them. All right. But b is a real number, I is imaginary. Okay, so it's if you're taking the square root of a negative number. All right, if you're taking the square root of a negative number. So if I can give you an example here just real quickly. I'm going to try to find the equation for it. All right, so if I'm taking the square root of negative, and I'll put it in parentheses, negative 16. All right. If I take the square root of negative 16, that's like saying I have the square root of negative 1 multiplied by the square root of 16. So if I do that, the square root of negative 1 gives me this lowercase I. Square root of 16, we can do that. That's 4. So I times by 4. And if you remember, when we write it, we get rid of the multiplication sign and we put that I last. So I have 4I. All right. So that is an imaginary number. Now a complex number is if I were to say this entire thing, if I said 2 plus 2 plus the square root of negative 16. We already know that this is going to give us 2 plus 4i, right? 2 plus 4i, because we just did that one, okay? So this top one here is an imaginary number, and what makes it a complex number is that we have a normal value plus an imaginary value, or a real number plus a imaginary number, okay? The discriminant here, okay, so the discriminant, moving forward, the discriminant is the thing that's under the square root, okay? So in our quadratic equation, this b squared minus 4ac, that's the discriminant. And if that's going to be positive, we're going to have 2 real solutions. If it's negative, right, we're going to have this imaginary, so we're going to have 2 complex solutions, but that means we have no real solutions, right? And then if it's a 0, we're going to have 1 real solution. All right. A root or an answer to the polynomial, right? So these guys, it's where it's going to cross the x-axis or touch the x-axis. So if I have 2 real solutions, that means I'm going to cross the x-axis twice. All right. And if I have no real solutions, I'm not going to cross the x-axis at all. At all. All right. How can you use the discriminant to figure out how many roots, right? You just look at the graph, or you figure out the discriminant, and then it'll tell you what the general shape of your graph is going to look like. So touching twice, touching once, not touching at all. All right, and again, that works the same way if it's opening up or down, doesn't really matter, okay? Again, it's talking about how many times it's touching the x-axis. We're almost done, bear with me. All right, so vertex. Okay, vertex is that max or that min point. And in order to do that, the x coordinate, you take the average of the x-intercepts, right? So if it crosses the x at both these points, right, we want to find halfway between that, because on that vertex is that axis of symmetry. All right, and that's where if we folded it in half, it would look exactly the same. All right, so we find the x-axis by taking the average of the x-intercepts. And then to find the y, just like normal, we plug the x back in and we solve. All right, what are the x-intercepts and how do we find them? Okay, those are the points where it touches the x-axis, and what we do is we change y in the function to 0 and we solve like normal, okay? And you can either solve by finding the roots or you can solve by doing the quadratic equation, whatever one works best for you. How to use the quadratic formula to find the vertex, okay? So this one, it might be a little bit confusing for you, okay? So you can do this or you can just do the process we showed up here, all right? But what you can do here is the quadratic formula gives you that negative b plus or minus the square root. If you take 2a and you divide both sides by 2a, right? So this side technically and this side there. You divide both of them by 2a. This first part right here, that minus b over 2a, that is your vertex. That is your vertex. Okay, so you could even just plug that in general. What is minus b over 2a? That's going to give you your x coordinate. All right, and what this guy's saying is you plug back in your x coordinate into your equation. All right, so same thing. Regardless, once you find your x coordinate, you plug it back in and you solve for y. All right, what does the discriminant tell you about the graph of a parabola? All right, again, it's going to tell you how many intercepts you have. Again, discriminant being the thing under the square root. All right. Imaginary numbers. Okay, so defining them using arithmetic. Okay, basically using math to figure out how to do them. All right, and then the one that was here that I really highlighted in the videos was that pattern for I. Right, so I is square root of -1. I squared is -1. I to the third is -I, and I to the fourth is 1. All right, so knowing that pattern, being able to know how to substitute in for that, that'll be super helpful. All right, nonlinear system of equations. Okay, so that was that substitution method. So again, just being able to solve 2 equations, 2 unknowns, right? You put it in the simplest form, you plug it into the other equation, and you solve like normal. And then inequalities, all right? So it's the exact same thing from the last one, solving the equation, but just realizing that you no longer have an equal sign. It's now some kind of inequality, right? And that inequality is going to tell you if it's a solid or dashed line, and then if you're going to shade above or below that line, okay? So we are almost out of time here, so I want to highlight a couple things here. All right, again, use this 311. Use 311 to your advantage. Okay, it gives you that study sheet, right? Can you do this? Can you do this? This is where it's found in the lesson. All right, so use that study sheet. Go through the checkup. Okay. Again, they give you the answers for that. So if you're feeling uncomfortable, go through that checkup again, and make sure that you again could stop your test, right? If you're unsure of something, go back and look. It's basically open note, right? It's basically open note. So please make sure you're taking the time and doing what you need to. Okay. Reminder: you are only taking the CST. You are only taking the CST. All right, you are not taking the TST, only the CST. All right, all of these should be unlocked for everybody. If you are having an issue taking this test, it might be because you forgot to turn something in here, but that should not be a problem. That should not be a problem. Okay, again, if you have that issue, email me immediately and I will fix that for you. Okay, all of that should be open for everybody.